Welcome everyone to another episode of the Verisian Community Podcast. I'm honored to have another guest from Bayer today on to talk about a very specific topic that's actually very close to the work that we do, which relates all about good programming practices in clinical programming. Especially with some of the products that we're going to be releasing now and in the short term, we're very focused on having a conversation and a debate really about what does it mean to write good code in clinical programming. And with us today, we're honored to have Cornelia from Bayer, from Berlin, or I think you're just outside of Berlin. Where exactly are you calling
It's
from?
still Berlin. It's very the last edge of it. Yeah.
Yes, excellent, good. No, I'm glad. So from Berlin, thank you for joining us and sharing your thoughts and your experiences to the rest of the world and to all of our listeners all over the world. And before we start, I'd love to ask you a little bit to share with our listeners your background and how did you start in clinical programming and perhaps more importantly, what made you stay?
Okay. First, thank you very much for having me. And yeah, it's a little bit not really straight line for me becoming a programmer. I first started as an lab assistant for biology, then studied computer science, where I would say learned a lot of the tools that I now also use on my daily basis. I first started on a CRO, and it was quite weird to get into this CRO as a data management programmer, because the only need for them was you have to read a SAS book, or for me it was just a sheet of paper where it was written, I have attended a SAS code. I didn't know anything about SAS at this time. It was just a sheet of paper because I saw a presentation 2 hours about someone explaining SAS and a little bit statistics. But it was enough to get into this company. And luckily, during my studying of computer science, I learned a lot of SQL, because databases was my specialty. And with this proc SQL, it was easy to adapt to all of the tools that you need to do. And luckily, this CRO was very specialized on this proc SQL. And so within a few days, I could start to be productive there. And then during this time, of course, I learned all of the tools that I need as a statistical programmer. And then when I joined Bayer about 1.5 years later, I know almost everything I need to at least pass the entrance test. And I have to say the job interview for at Bayer, it was the most challenging, but also the most funny thing that I
Really?
ever did, because when I came there, the people in this group, they usually used data steps, and
Right.
I came from the proc SQL world.
Yeah.
And during this interview, we more challenged that than doing an interview. So
Yeah.
usually we found some use cases and try to do this with data step and with proc SQL. And it doesn't felt like a job interview. It was just fun.
Yeah. What do you believe constitutes good SAS code, or specifically good code when submitting a study for, submission?
I would say first it's about everything that you write in code. You should have a very good documentation about it, so that other people can understand this. You need, of course, kind of validation. So at Bayer, for example, we divided our programs into 3 types. We have these standard macros that gets validated quite intensively with a lot of use cases and stuff like this. Then you have the very intensive calculations on steady basis, where you have someone else to double program everything to make sure that your numbers are right. And the third level is to have someone that reads the code and understands it, checks the logs, and then say, yes, that works, or it works not. But if you have just code, pure code, that maybe it's quite complicated to read. Let's say you have someone using ProcSQL and you have more than 3 or 4 potential data steps in this ProcSQL statement. No one can understand this. So having such code, it's hard to validate, and also later on it's very hard to maintain this code. So I would say having a good documentation in there, that means, have some notes around your code and then try to write it easy. Either make an additional step or 2 instead of trying to put everything into one.
How prevalent are those conversations? For example, at Bayer, is there a lot of focus around code quality, in this case, documentation, some of the stuff that you mentioned? How is that sort of maintained, or does every programmer, in your view, has a different programming style, and you just have to make do with that?
So at Bayer, first we have a very nice programming environment. It means if you start a program that it's meant to really run on a productive use, you first initialize your system, you initialize your study, and you do everything with standard macros. So no one needs to take care about that it's just 2 lines of code and then your system and your study is initialized. The same is for creating outputs, tables, figures, and also doing the standard mapping steps from, for example, SDTM to ADS. Everything is standardized. That means that looks very similar on each of the studies. The only freedom on programming is the steps in between.
Yeah.
And there, of course, you can see some differences. So, for example, when I started at Bayer, I came from the ProcSQL world, and the other ones was data step users. And for me, it was hard to find someone who validate my code because no one was used to this ProcSQL. Luckily, there was some colleagues that was willing to learn this ProcSQL. And then I would say half a year after this, everybody get used to the SQL and me get used to the data steps. And then we try to get the best out of it. And sometimes in my code, I have ProcSQL followed by a data step, then followed by ProcSQL, followed by a data step, because on this way you can just get the best out of both worlds, I would say. Yeah. But I think people, they work close together. They also share their knowledge, and then over the time they do similar things on their code.
And have you ever gone into anyone's code base or maybe a new study where you thought this code base is a mess and it must be cleaned up, or there's just really bad documentation?
Yes, of course. So my actual study that I'm working on, we
Right.
just bought the drug, and with this we got all of the studies and also the programming on the studies.
Right.
And as usual, there is only less time, so that means we just took over what we get, tried to make this running on our systems, and used it. But I would describe it like dinosaur code. So I would say there are
Dinosaur
steps
code.
drin. I really needed to Google because no one is using it anymore to understand what the stuff is doing. I would say 100 of lines of this code we probably can do with maybe 10 or 20 on a great merge, or maybe also with ProcSQL. So yes, it happens.
But do you think that's more about, is that just different practices, given that, for example, your case, you're very used to using ProcSQL statements and procedures, or is that more of, where do you draw the line between the style of programming versus the actual quality of the code itself?
I would say when I really need to go through 50 lines of code to, at the end, understand what the programmer is doing, then that's probably not really a good code, especially if I can do the same also with data steps. You can be a lot more efficient than it's done in this kind of code. I guess the reason behind is if you have a SAS programmer that maybe started with SAS version 6 or 7, when it was really the beginning of SAS, they get adapted to this and they use it. But in meantime, there is so much progress in also on the SAS databases, on the language, on the possibilities that you have with this code, that in newer time you can write it a lot easier, a lot faster, and also better readable, I would say.
What do you think the regulators think about code itself? What's your experience been with if at all, by any of the regulators worldwide on code quality like that?
So right now we don't had any feedback from any of the agencies that our code was not working, or that it was written in a not readable style or so. We more have the problem that we use macros, and our macros are within a catalog, they are compiled, and they are in a way that the knowledge stays at Bayer, so that no one else really knows what it's within this macros. And when we submit something to the authorities, some of them really want to run the code, especially, I guess, a Chinese agency. They really want to make sure that the code that you submit really belongs to the data and that everything at the end came to the same result that you sent on your clinical report. So it's for us, it was more a challenge to give them code without macros. Meantime, there are also tools that do this. So we have some very good programmers here, and they do all this fancy stuff that usually you can only dream of. But yeah, with this tool, it's possible.
Interesting. And what do you think this question relates to SAS, but obviously with all this interest into R, it starts to become more of a general question around programming itself. So if we talk about what are the biggest challenges that you come across, if we were to generalize, what do you think are those challenges when writing good clinical code, and are there differences between when going from a SAS code base to an R code base, which some sponsors are farther along than others? Curious to hear your thoughts on that.
So I have to say I'm really a pure SAS programmer. My R knowledge it's very very limited. So I probably cannot say much about switching from SAS to R. I know there are some companies that they already did this and they also was able to have a whole study on R. At Bayer we have some colleagues that also dive into this topic and program some steps on R. But I have to say our whole environment is so SAS focused right now that it might take some time to change from SAS to R. But I know that there's also another thought of changing from SAS to R because it's really hard to get SAS programmers. So people, they are statisticians or so, they are used to R, but usually not to SAS. So that's one of the points. The other point, it's probably the license and the cost that you have if you use SAS.
And how big of a problem is that indeed? Clinical programmers have a very unique skill set. You're someone said to me that a clinical programmer is basically a jack of all trade, but a master of none, because you need to know about statistics, you need to know about your therapeutic area, you need to know about computer science. How do you see that, especially in relation to the fact that we need more good statistical programmers? SAS is not really a language that especially gets taught at university. R is a much popular language. Some people even speak about Python, but that's probably even farther out. Do you see that as a real challenge in the clinical programming space?
That's really a hard question. So I would say, yeah, at Bayer we are SAS focused. I have heard that it might be hard to get good people, but we have all these CROs. And for a company like Bayer, it might be not that difficult to get good people. It might be more a challenge for CRO. Or you have to train your people. So maybe it's not getting people with a good SAS knowledge, but people that are willing to learn quite fast and to adapt quite fast to a new environment. And then maybe you spend 2-3 months to get them into SAS, especially if they come with a little bit programming background. It shouldn't be that hard. And with having these new tools in mind, like ChatGPT or so, it becomes even more easier to learn a new language if you already know one. So, for example, you just type a piece of R code in there and then say, please translate to SAS, and then you get usable SAS code out of it. And I would say that that's a good way to learn it. The switch from SAS to R, I don't know. I mean, everybody it's talking about it, and I guess everybody it's playing around and trying. But we, as a statistical programmer, especially in the pharma companies, we work with SAS since. I mean, I worked at Bayer since 15 years, and they was there into SAS probably long 10 years, 15 years, even more on it. So everybody, it's really deep trained in SAS, and it's hard to get this out of the head, especially if you have a good environment that supports you very well, as we do have. We have our macro catalogs, and it might take some time to really get companies into different language, especially companies that are traditional, I would say. So like Bayer or Roche or others, they have a big knowledge on this language, and yeah, it's hard to get it out.
The investments in macros, existing macros, there's been so much work on building those infrastructures that changing those is you can't just, the opportunity cost there is tremendous if you were to switch completely. It is interesting though. I mean, for me, especially coming from more traditional open source perspective, I mean, ultimately, whether or not you use open source actually doesn't really matter. It's really more about what's the best tool for the job. And in my view, a little bit on this whole open source versus SaaS debate, which, to be honest, I don't quite think is a debate itself, because again, it's about what's the best tool to get the job done. And what I see mostly is that, especially for, I guess to your point, for CROs, that it's easier to hire R programmers than CROs. And but I think the whole culture of open source is useful to the extent that it can be used within sponsors that are newer, that don't have the infrastructure like Bayer, because you can't just get rid of that given all the work that has been done before.
Yeah, that's true. So as you already mentioned, there will be a change, and the change probably will come from the CROs, and then will get set also to other companies. So we probably cannot hold it anymore, and I think it's also a good idea to just check what is possible, and if that's a better way using R or Python or other tools, then why not change? For Bayer, I would say bringing these new tools in, you have to do a lot more than just adapting the programs or the SAS code that we create as a statistical programmer, because you have to recreate all of the macro catalogs, you have to recreate all the tools that connect to studies, all the environment, and that's a lot of work, and you need to find someone who is willing to do this and also to pay for it.
Yeah, that's difficult. What advice would you then have for any aspiring clinical programmers? What should they think about? Because you've got a computer science background.
Yeah.
What's the most ideal background for someone to have? How do you see the best way how a statistical programmer can educate themselves?
Yeah, so I can say from my perspective as a computer science, I really have a lack of statistical knowledge. Right now, I'm just doing a Coursera course about the beginning knowledge of statistics. So really the basic, because I really came across that I miss this information, or that I miss this knowledge, and I need my statistician to feed me up with this and explain stuff like this. So I would say a mixture of at least the basic of statistics, so the normal things that you need to know, t-test, p-value, everything like this, you should really know. And then also have interest in programming languages. And I would say it doesn't matter from which language you come. At least if you have a ground knowledge about the loops, the if then else clauses and stuff like this, as long as you have this, you can be fast in learning some new stuff. And there's a lot of YouTube videos out there. There are some courses, there are tools. So it shouldn't be hard, a complicated thing to get used to it, to learn it and to adapt this.
Do you think, though, you have a different perspective, though? Someone that studies statistics may have less appreciation to, I guess, programming or computer science, the science that goes behind the scenes when you write instructions to the computer, and therefore what that means to write good code, because writing good code is instructions to the computer, but also how do you make sure that the code is readable, is understandable by, well, firstly yourself in a few months' time, and your fellow programmers, versus the statistical knowledge you need to know to do the subject matter. How do you see that?
You can learn everything. So if you come from a statistic perspective, it's probably not hard to just get to know how you have to write a good code, that it's good understandable. So first, of course, you have to make sure that you self understand it, and then you have normally a good connection to your validators. If you get some feedback that they don't understand it, then you probably have to change something. So I would say it probably doesn't matter from which way you come. You have to learn the other one.
I like what you said at the beginning. You can learn anything. That's probably going to be the headline for this podcast. What do you think for us as a team with Verisian? What could we contribute in when it comes to writing and or when it comes to building good analyses? From what you've seen so far, the demo, the webinar, our conversations, curious to as a final sort of, as we're concluding this episode, curious to hear your thoughts.
I have seen some very nice demos from your Verisian, and I have this study with this very old style code. Having a tool that just reads through the whole code and don't get tired after, I don't know, the first 1,000 lines. That's really great. And then creating an overview about just what gets into the code, what kind of data sets, what comes out, where the variables are connected, so that it's something is especially when it comes to big studies with a lot of mapping and calculation and stuff like this, that it's very, very helpful to see just with the first glimpse what happens there, where you maybe have to dig deeper into it to understand a specific variable, or to know how a specific data set is created. That it's quite, I would say, the very big advantage from your tool, from Verisian. And also checking the log for maybe dead ends of data sets. So if there is maybe something that it's created but ends somewhere blind and it's not used anymore, that's also a good thing, because especially such cases lead to maybe code that do unexpected things. And that's something that we definitely need to avoid when it comes to information that we want to send to agency, where we want to prove our product. We cannot risk that there is anything in there that maybe calculates something wrong or so. So in this case, Verisian will be a very, very helpful tool. And also, I know that you plan the validation parts to really read through code and make sure that the code itself makes sense and it's right. That it's also something that will be very helpful.
I appreciate that. We'll continue to work hard and hopefully deliver on those promises that we've made and so far have hopefully been able to demonstrate. So with that, we're getting to the end of this episode for the podcast. I'd love to ask you, Cornelia, is there any final remarks or anything else you want to share to our listeners, whether it's related to good programming practices or anything you want to impart to our audience?
Yeah, I have to say, being a statistical programmer, it's very a nice job. You learn a lot of different tasks, different sites. So, for example, you get all of this clinical studies. You learn a little bit about the different drugs, and also you get very good perspective about the tools that you need. With looking a little bit around on the on so in other directions, you can also connect to other functions like the medical writers, so the data managers, and also to other computer science. And especially now with this all this change with the AI things that are invented recently, it will be very interesting and a very challenging time in the future, I would say.
Definitely interesting. I think something that we've seen a lot with different organizations, biostat organizations, is that they know something. They know that in 5 years' time everything will change, but no one really knows what it is.
That's
And
true, yeah.
and that's, I mean, that's a very exciting place to be in, obviously, for those that like change and innovation, obviously. Great. So Connie, thank you so much for spending time with us on this episode. It's been an absolute pleasure to speak to you, to hear about your background, to hear your thoughts on this. Hopefully, we'll probably get you maybe on another podcast later. And we are planning to do a conference at the end of next summer, which is already next in 7-8 months time. So hold me on those words, probably in London. And we'd love to have you there, and hopefully you'll get to meet some of our listeners and the rest of the community also. So with that, I thank our listeners for staying all the way until the end. If you have any topics you'd like to contribute, that you'd like us to discuss or speak about, reach out to me. If you'd like to reach out to Connie, I think they can reach you out directly on LinkedIn. Would that be okay, Connie?
Yeah, yeah, that's fine. Thank you.
Great. We'll put the link on our LinkedIn if you want to learn more or continue the conversation. So with that, have a very good evening, and I'll speak to you very soon. And thank you everyone for listening. Have a very nice day. Bye-bye.
Thank you very much for having me.